Hello everybody and welcome to an enVision's Algebra 2 Topic 3 Lesson 5 Example 5 video. So in here we're going to solve the polynomial equations and then we're going to try it. So we have this very nice, very long and very beautiful polynomial. So I'm just going to rewrite it because I just write a lot bigger and this is not enough space for me to write in. So let me just rewrite this out as 2x cubed plus 5x squared minus 3x equals 3x cubed plus 8x squared plus 1. All right, to find factors, and remember the factors are the zeros of the graph. My equation, one side of it has to be equal to 0. And in our case here, it's not. So I'm going to rearrange all of these so that one side is going to be equal to 0. And what I'm going to do is, my plan is to keep the leading coefficient positive. And since my highest degree here is 3, and I have a 2 and a 3 here, I'm going to subtract the 2 to the right side, so that I can keep this leading coefficient positive. Right, then on the same line, just so I could reduce reduce paper waste here, I'm just going to keep following suit. I'm just going to subtract that 5x squared. And then I'm going to add 3x. Now on the right-hand side, I don't have a 3x to combine it with, so I'm just going to kind of move it out to the side. And as I add down, I'm going to put this in standard form. So this whole side became 0, 0. And this side is 3 minus 2 is going to be x cubed. Again, combining my like terms. 8 minus 5, 8. That's going to be 3. Okay, looking at my degrees, counting down, the next one I'm going to take is this plus 3x. And then the plus 1. Oh, sorry about that. All right. Now looking at this, what I think I'm going to do is I'm determining if I want to factor by grouping, but I don't think that's going to work here. So what I'm thinking here is I'm looking at this polynomial. I was thinking about factor by grouping, which basically means what we do, and do not write this down. This is my thought process for you. Where I take this first set, I group it, then I take the second set and group it. Do greatest common factors. That's just going to be 3x plus 1. There's no way I could pull anything out of there. But these two factors are not the same. So I determined that didn't work. So I'm going to look at other avenues. So the big thing I'm going to look at here is I'm going to look at my coefficients. And my coefficients are 1, 3, 3, 1. And I know from Pascal's triangle that when you have a plus b cubed with the n cubed, you get coefficients of 1, 3, 3, 1. So I know that this is going to be used for that binomial theorem or identity and Pascal's triangle. So here we have the 1, 3, 3, 1. My a must have been x because x cubed, so we count down on x. And my b, I'm going to say is 1. Because if I think of this is a squared plus 3a, sorry, not a squared, a cubed. And I'm putting in these coefficients for Pascal's triangle. b1 plus 3ab squared plus b squared, p cubed. And b cubed is 1, which means b had to be 1. All right, so then we're going to be looking at x plus 1 cubed. Now here's the thing. If 1 happened to be negative, you would see this positive, negative, positive, negative. You would see the operands change from positive to negative. So this is going to be a positive, and we get, because each one of these is positive, so we get x plus 1 cubed. All right, so my solutions for this are going to be x equals 1 with a multiplicity of 3. All right, so let's go look at the solution. Let's say 1. I think it's negative 1. Because this is equal to 0 at Pascal's triangle. Maybe think of other things. So again, they use a zero product property, set that equal to 0. They get x equals 1. So you have the solution to the equation is x equals negative 1. And again, like I said, this has a multiplicity of 3 because it does actually theoretically go through negative 1 3 times. Okay, so let's look at the vocabulary. A polynomial equation is an equation that can be written in the form of p of x equals 0, where p of x is a polynomial. Again, we did that. We got this equal to 0. I did mention in class that you should probably know Pascal's triangle up to the 1, 3, 3, 1. The 1, 4, I think it was 1, 4, 8. But I would definitely have Pascal's triangle in your notebook. No, 1, 4, 6. And if you really want to know how to create it, these are triangular numbers. These are counting numbers. So this is all ones, then 1, 2, 3, 4, 5, 6. Then this is 1, 3, 6, 10, 15, 21 are triangular numbers. And so on and so forth. But again, I would know the 1, 4, 6, 4, 1, at least up to there, so that you could identify if you do have a binomial, a cube of a binomial, or an n of a binomial. Alrighty, let's look at this one. You do have 2 that need to be completed. This one has a greatest common factor of x, so when you do go into factoring, you're going to get into that x cubed. And this one will have the x cubed fall out. So, yep. So if you have any questions, please ask, and I'll see you in the next example.